right, so I've shown in the notes, well, earlier in 2.2, we talked about how the derivative of sine of x is cosine of x, and the derivative of cosine is negative sine x. And we may not have worked out all the details in class, but I probably alluded to the fact that you could use the angle addition formula for sine of x or for cosine of x to take the difference quotient, take the definition of the derivative, and prove that the derivative of, say, sine is cosine. And the derivative of cosine is negative sine. And we left it at that in the first section with your basic rules for derivatives. Now that we have the quotient rule, we can more efficiently find the derivatives of these other four trig functions. So tangent, cotangent, secant, cosecant. Like I said, using the quotient rule helps us work those out. I'm not going to do all four in this video. I wanted to start with them all on the board. I'm going to prove the first two, and then you would use a very similar process to take the derivative of cotangent or cosecant. And it might be a good exercise to do on your own, by the way. Once you see how to take the derivative of tangent, you could try taking the derivative of cotangent and see if you can get negative cosecant squared. Anyway, all right. So I want to prove to you that this is true. If you're curious about why, it is easier to remember these rules if you have some idea why they're true. So let's suppose I'm just going to write f of x equals tangent x. And let's express tangent x as sine over cosine. The reason I would want to do that is, okay, let's say I don't know the derivative of tangent x. That's my whole point right now, is I want to try to figure out what the derivative is. I do know the derivatives of sine and cosine. So if I can express tangent in terms of sine and cosine, then I can now use the quotient rule to take the derivative of this ratio and get the derivative of tangent. So the derivative here will be, if we apply the quotient rule, so it's the bottom function, cosine x, times the derivative of the top. Derivative of sine is cosine x, minus the top function times the derivative of the bottom. Derivative of cosine is negative sine x. All divided by the bottom function, cosine x squared. Okay, so I've got cosine times cosine, that's cosine squared, minus, but then this is negative sine x times negative sine x, so that's positive sine squared over cosine squared. And so depending on how fresh your trig identities are in your head, but if you see cosine squared plus sine squared like this, maybe there's something kind of dinging in your brain that says, oh, wait, that reminds me of some trig identity. That's your most basic Pythagorean identity in trigonometry. Sine squared plus cosine squared is equal to 1. So this is equal to 1 over cosine squared. Now, there's another trig identity that says secant x, you can see it if I write it over here. Secant x is equal to 1 over cosine x. So if we have cosine squared, well, that cosine squared we could write as cosine times cosine. This is the same as 1 over cosine x times 1 over cosine x. So secant x times secant x, this is equal to secant squared x. And there we go. Yep, so we have that rule. Derivative of tangent is secant squared x. So it's using quotient rule and a couple of trig identities. Now I want to do the same thing for secant x. And this identity, I'm gonna use this identity. I guess I'll get rid of all this. Okay, so now let's say f of x is equal to secant x. If I'm now wanting to prove this rule here, secant x is equal to 1 over cosine x. And so again, I want to write it in terms of derivatives that I know, or functions whose derivative I know, I should say. So quotient rule here. So it's the bottom function times the derivative of the top. well, if the top's just a number, then the derivative of the top is 0, minus the top function times the derivative of the bottom. Derivative of cosine is negative sine x. All of that divided by the bottom function squared. Okay, well, so we've got cosine x times 0, so that's 0. A negative times a negative here, so this will be 0 plus sine x over cosine squared x. So that's sine x over cosine squared. I'm going to write that as cosine x times cosine x. And I'm going to write sine x as sine x times 1. I'm going to try to block the glare for a second. And the reason I want to write them as products here is so I can separate out, okay, well, so I see a sine over cosine, so that's equal to tangent x. And then I see a 1 over cosine, and so that's equal to secant x. And so this right here, the sine x over cosine squared x, can be kind of separated out or teased apart into sine over cosine, which is tangent, times 1 over cosine, which is secant. And so the derivative of secant is secant x tangent x. I mean, I wrote it in the opposite order, but it's multiplication. Order doesn't matter. So multiplication is commutative, is how I should say that. All right. And so, yeah, if you want to test out, you could go ahead and work on the derivative for cosecant, which is 1 over sine, use the quotient rule, or cotangent, which is cosine over sine, use the quotient rule. And you can show that the derivatives are what I gave you in the notes there.